Today then we're going to continue working with systems of linear equations, and we're going to solve them by hand today. So instead of graphing them, we're going to do them algebraically. And so we've got two methods for doing that. One is substitution and the other is elimination. And then we're going to look at classifying them again and what happens if we use substitution or elimination for classifying them, just like you did yesterday with looking at the slope and the y-intercept. And then we're going to look at an application problem also today and you can pick your way of using substitution or elimination for solving that. Right. So still the whole objective is to find the point where these two lines intersect. And there's just the two different methods for doing it algebraically. One is substitution. So, well, what is substitution? Well, it's just kind of like when you are evaluating something. You can plug something in for something else. So this variable equals this thing, so wherever I see this variable, I can put that thing in there. Okay? So in this first one we have, if y equals x minus 1 and x plus y equals 7. It tells us that y equals x minus 1. So that means that wherever I see y, I can replace it with x minus 1. So I will go to the second equation then, and where this y is, I'm going to replace that with what it equals. So I'm going to replace it with x minus 1. And so by doing this, this allows me to, instead of having two equations with two variables, I now have one equation with one variable that we can solve. So we add the x's together, and now it's just a matter of solving for x, all right, which you've done a lot of that, so that part's the easy part. Right, so we solve that and we get x equals 4. Right, okay, well that's fine. That gives us the x coordinate, but we still need the y coordinate. So lots of times what happens, if you're going to miss something, it's because you stop here. Okay, you need to remember that now I need to take that value of 4 and put it in here for x so I can find the value of y. So y equals 4 minus 1, which is 3. And then you've got to remember to write it as a point. So my answer is the point 4, 3. All right, don't just leave it as x equals 4 and y equals 3. You have to actually write it as a point 4, 3. So lots of times they give it to you, say, all right, y equals this or x equals that right away, and you can go ahead and use substitution and solve. Sometimes, though, it's not written out that way. We actually have to do a little bit of work before we can do that, all right? So we can solve for x or y first, whichever one is the easiest, so that our goal is to get either x or y by itself. Okay? And once we get x or y by itself, then we can go ahead and do substitution. So I'm looking for, in either equation, where there's just a 1x or 1y. Right? And when I find that, then I'm going to use that equation and solve for that variable. So in this case, in the first equation, we have, so in this first equation, we've got just an x there. All right? So since I have just x, I'm going to solve for that first. So 2y plus x equals 4. All right, so I'm going to get x by itself, so I'll subtract 2y to start with. And you can write it either way you want. So 4 minus 2y or negative 2y plus 4. Right? So my first step here was to get x by itself. Now that I've done that, I'm going to take that value then, and I'm going to replace that x with it in the other equation. Right? I use the first equation to find out what x equals. Now I know what x equals, so I'm going to replace x in the other equation with that. So we have 3 times negative 2y plus 4 minus 4y equals 7. So then we just go through this process of solving this equation then. So remember here we have negative 6y, negative 4y. They're on the same side of the equal sign, so we just put them together. So when we finish that, we get y equals 1/2 or 0.5. So you can use decimals or fractions there. It's completely up to you. So now that I know the value of y, I can take that value of y, put it in here where I've solved for x already then, and find the value of x that goes with it. All right, so negative 2 times 1/2 is 1. Negative 1 plus 4 is 3. So my answer then, once again, is a point. All right, so you got to make sure you write your answer as an actual point. Don't just leave it as x equals and y equals. Okay. All right, so let's look at elimination then. So there's substitution. Elimination means what the word says, right? We want to eliminate either x or y. Right? So what happens, first of all then, is I have to get either the x's or the y's must have opposite coefficients to be able to eliminate them. Right? Which means that if x is 4, then if I have 4x in one equation, I want negative 4x in the other equation. So that I can, what I'm going to do is I'm actually going to add them together, and then to eliminate, that means that one of them is going to go to 0. Either the x coefficient or the y coefficient is going to be 0. So if we look at this first example, we can see that here we have a positive 2y, here we have a negative 2y. Because those coefficients are opposites, when I add them together I get 0. So what that does is eliminates the y variable, and then I'm just working with x. So if I add these together, I get 7x, and 2y minus 2y is 0, so I don't even need the y then, equals negative 14. So we divide by 7, x equals negative 2. Right. Now, when it's set up like this, all right, the substitution method actually gives us, it's harder to find the first variable, easier for the second one. All right. This one is easier for finding the first variable, harder for the second, because we've got to take that number and put it back into either equation. Okay. So now I know that x equals -2. I can use the first equation or the second equation to find y. Right? Does not matter which one. It's completely up to you when you're doing it. Right? I'm going to go ahead and use the first equation. So 3 times -2 plus 2y equals 4. And then you just need to solve it. And then once again, make sure you write your answer as a point. And a reminder then that you can check your answer by, since I used the first equation to find my y value after I found x, if I want to check this point to see if it's true or not, then I would go to the second equation and use that one to verify it. So I'd go to the second one, do 4 times -2 minus 2 times 5, and see if that equals -18. Right? If it does, then I did it correctly. All right? Now the other thing is that, like I mentioned yesterday at the end of the day, that all of these, okay, you can use Desmos, right, to check them also. Right? Because with Desmos, I can just type them in as they are, and it will provide me with the answer. Okay? All right, and let's take a quick look at that. All right. So we have 4x plus 2y equals 4. All right, so it'll graph that line. It doesn't matter what form it's in. I did that wrong, didn't I? Because that was 3x. Correct? That was a 3, right? Okay. 3x. Okay. And this is 4x minus 2y equals -18. Okay. So when you put them in Desmos, then you got the intersection point. You can see it. If you can't see it, you just make your graph bigger. And if you just click on it, it'll actually give you that answer. So I can tell now by using Desmos that I just verified that my answer of -25 was correct. Okay. And the nice thing about that is, like I said, is that you can type them in as they are, unlike your calculator where you've got to have them in slope-intercept form. Okay. All right, let's look at another one. All right, 3x plus 5y equals -16. 2x plus 3y equals -9. All right, so I've given us some steps in this situation. All right, we're looking to get x or y opposite coefficients. All right. So that's the first thing we have to do. Second thing then, we'll add the equations and solve, find the other coordinate, and check our answer. Now, in this situation, it's not so nice. All right, we don't have them the same. So what I have to do then is I need to pick which one I want to eliminate. It does not matter which one it is. All right? So what we have to do is find the least common multiple of the coefficients of x or the coefficients of y to eliminate them. All right? So we're going to work with the x in this situation. So 3 is my coefficient for x in the first one. 2 is the coefficient for x in the second one. What is the least common multiple for 3 and 2? All right, smallest number they both go into. What is it? 6. Okay, now, you can look at it that way, or you can actually just think about multiplying them together. Okay? So what we're going to do is that the thing is that one of them's got to be positive, one of them's got to be negative. So what I'm going to do is I'm going to multiply the first equation. And remember, what I do to one side of an equation, I have to do the other. I'm going to multiply the first one by -2. And I'm going to multiply the second equation by +3. Right? Because this is then going to give me -6x and a +6x. So when I add them together, I get 0x. So these have to be opposites. So I'm going to, in which one you make negative doesn't matter. Okay? All right, it's completely up to you. Now I could have done the y's, and I would just multiply the first equation by -3, the second equation by +5. All right? It's up to you which one you do. All right, so now I get -6x minus 15y equals 32. All right, I multiplied everything by -2. Then the second equation, I'm going to multiply everything by 3. So we get +6x plus 9y equals -27. So my x's, the coefficients are now opposites. So when I combine them, add them together, those go to 0. I get -6y equals I think I multiplied wrong, didn't I? All right. I think 2 times 5 is 10. All right, so that should be -10y, sorry. So we get -y equals 5. Right. And if I multiply or divide by -1, we get y equals -5. So we found the first one. When we go to find the second one then, we're going to go back to the original equations. Don't use your altered ones. Go back to the original equations. Pick your favorite. Okay? Maybe you're a 1 person, maybe you're a 2 person. So do the first one or do the second one, whichever one you want. Put -5 in for y, and we'll solve for x. So I'm going to take the second one this time. 2x plus 3 times -5 equals -9. Oh, 2x minus 15 equals negative. All right, and just go ahead and find the value of x. And then just remember to write it as a point. And then always a good idea to go back and check your answer to make sure you did it correctly. All right. So substitution, get one of the variables by itself. Plug that information into the other equation. Elimination, we want to get either the x or the y, whichever one you want to. Have the coefficients be the opposites, so when you add them together you get 0. So you've eliminated that variable. You're just working with the other one then to find that one. Once you're done, make sure you write the answers as a point. Okay. All right, classifying systems using substitution or elimination. Well, we found that I can classify them just by getting them in slope-intercept form. Okay, and if you want to do that, you can do that. Right? It's completely up to you. Right? Now, the two things we're looking at here, though, when we're doing it with substitution or elimination, basically we're going to look at this as elimination. Right? Is that the thing to remember, and this happened on the test the other day actually, is that an identity such as 0 equals 0. So in other words, if I do elimination and everything disappears, all right? So I get 0 equals 0, okay? That's called an identity. That's the situation where we have an infinite number of solutions, right? That means they're the same equation, basically. All right, that's the same situation we had yesterday where we get the same slope and same y-intercept. Right? A contradiction is when we solve it and we get like 1 equals 3. Well, 1 never equals 3. Right? In those situations, those are the ones where we would have parallel lines if we put them in slope-intercept form. Right? And so there's no solution there. So if we get 0 equals 0, infinite number of solutions, that means they're consistent and dependent. If we get something that's equal to another, one number is equal to a different number, then you have a contradiction. Those are inconsistent and there's no solution. All right, so let's take a look at this one here. We're going to go ahead and use elimination to do this. All right, so first thing that you need to do when you're working with elimination, if the variables are not written in the same order, then you need to rewrite them so they're in the same order. So we like x, then y. So the first one we have 3x plus y equals 1. We'll leave that one alone. The second one is 6x plus 2y equals negative 18. All right? Just rewrite them so that your x's and your y's are in the same spot. All right, so to use elimination, we need to have the coefficients be opposites. So we're going to multiply the first equation by negative 2. So sometimes you only have to do one of the equations. You don't have to do both. Once in a while you have to do both. All right, so we get negative 6x 2y equals negative 2. Right. Hey, look at that. All right, everything on the left side is the same. All right, so negative 6x plus 6x is 0. Negative 2y plus 2y is 0. So on the left-hand side we get 0. And the right-hand side we have negative 20. Right? So when does 0 equal negative 20? Okay, never. Okay, this is never true. So that means it is inconsistent. And there is no solution. Okay. So either we're going to get an answer like we did when we were doing substitution elimination to start with, right, which is consistent and independent, or you're going to get this situation where the left side is not equal to the right side, so they're inconsistent, no solution. If you get 0 equals 0, then they are consistent and dependent, so it's infinitely many solutions then. Okay. All right, let's look at an application problem. Veterinarian needs 60 pounds of dog food that is 15% protein. Right? Got to help your dog be healthy, right? Get that protein in them. My wife gives our dog scrambled eggs every morning in her dog food. Okay. You will combine a beef mix that is 18% protein with a bacon mix that is 9% protein. How many pounds of each does he need to make the 15% protein mix? So the first thing we need to do is, now unlike the one yesterday, right, where it was going to be y equals for both of them, in this case, it's going to look, we're going to have this look that we have ax plus by equals c, and not c, I can't use that. like EX plus FY equals G, all right, something like that. All right, so you're going to have two equations, and then we'll end up, we can use substitution or elimination to solve them. Lots of times you use elimination. You could graph them either way, all right? But they're going to be in that form. The first thing you've got to do then is you have to identify what you're going to let equal X and what you're going to let equal Y. All right? So when you get that final answer, that point, you know what they're referring to. All right? So in this case, we're going to let X equal the beef mix, and Y equal the bacon mix. I should say the weight of them. Okay, so this is beef mix weight and bacon mix weight. All right, because we're talking about what we want to know is how many pounds of each. All right, so X is going to represent the weight, how many pounds of beef mix, and Y is going to be how many pounds of bacon mix. All right. So most of the time, your first equation is going to involve just those two things and a set number. So it says that we want 60 pounds of dog food. So the amount of beef mix plus the amount of bacon mix is going to be equal to 60. Right. Then we will use what we call the parameters of them. All right. The parameters here is that there's 18% of the beef mix is protein. Okay. The bacon mix, 9% of that is protein. All right. And our total is going to be 15% protein. So when we write this next equation, then it's got to involve those numbers. Right? So all of this beef mix I have here, X, there's only 18% of that is protein. The bacon mix, only 9% of that is protein. Now the key is to remember is that with the final mixture, only 15% of that is going to be protein. Well, what is that? 15% of what's going to be protein? Yep, 15% of the 60 pounds. All right, so I used all of this first equation. All right? Just I used it all with the different values there. Like you might have a situation where it's people going to a movie. All right, 50 people went to a movie, children and adults. If children paid $3.50 a ticket and the adults paid $6 a ticket, and all together they made $100. All right, how many children, how many adults went? Okay, so you would still have this, like this first line you have quite often, and then the second line is the one that ends up changing a little bit. All right, so let's simplify this a little. Right? So we have X plus Y equals 60, and 0.18x plus 0.09y equals, well, what's 15% of 60? Anybody know off the top of their head? I don't either. So what do we do to find that out? A little multiplication, all right. Is it 9? All right, okay, equals 9. All right, so here's the two equations that I'm working with. So you can use substitution or elimination to do them, whichever one you want. Right? Now, for me, I'm not a big decimal guy, all right? So I'm going to, these are kind of tough with those two decimals, so I'm actually going to get rid of those decimals to help me out. So I'm going to rewrite it. So we've got x plus y equals 60. And how can I get rid of those decimals? Multiply everything by 100, right? Okay, move the decimal two places. Right? So we get 18x plus 9y equals 900. Now I'm just doing that so that I'm not necessarily working with decimals. Right? So now we've got those two equations, we got them to where we can use them. Now we can use either substitution or elimination or graphing to find the solutions for them. Okay? I'm going to use substitution, or I'm going to use elimination, so I'm going to multiply this one by negative 9. Right? I'm going to eliminate y. And I'm just going to move it down here below this other one. So 18x minus 9x is 9x, and that equals 900 minus 540 is 360. Divide by 9. So we get x equals, and what's 360 divided by 9? 40. Okay. So if x is 40, then y must be, no, x plus y is 60. So if x is 40, then y is 20. Right? So now instead of writing this as a point, you're going to write a sentence to tell me what it means. So what are we talking about here? We're talking about a veterinarian. So spell his name right. Will need 40 pounds of beef mixture and 20 pounds of bacon mixture. All right, so you've got to finish that off with a sentence that explains what it means. So it's a little bit harder just because there's a little bit more work to do. Now, I use, like I said, I use elimination. You could use substitution also. You know, solve for x or solve for y if the equation x plus y equals 60. Right? You could use that method also. It just kind of depends on what you're most comfortable with. Right? I like the elimination method, so I like to use that. Right?